AI is also more accessible than ever before.
Okay, so welcome everyone to the seminar today. Let's start our fireside chat and a seminar, online seminar today for the third time for Data-Centric AI competition, first time in Vietnam. So please welcome our speakers and our guests today. First of all, let me introduce myself. My name is Phong. I am currently a visiting researcher in MILA, Quebec, AI, Canada. And we have Mr. Tuấn. Is the technical leader of Data-Centric AI competition in Vietnam. And our first speaker today, please welcome Miss Huyền. We usually call her with a very warm nickname called Chip. So please welcome Chip to the panelists. So the technical team, can you push Chip to the panelist spotlight? Yeah, so maybe Tuấn, can you please introduce a bit about yourself? And after that, Huyền Chip will have a short introduction.
Okay. Hi, Mr. Phong. Hi, Mr. Huyền. My name is Tuấn. I'm a technical leader of Data-Centric AI competition in Vietnam. Also, I'm a data scientist in FPT software. So nice to be here with you guys and hope you have a good and informative seminar today.
Yeah. And Tuấn and Huyền actually share the same hobby, I would say. They both wrote incredible books. So Tuấn wrote a very good book in basic deep learning. And of course, Huyền Chip, everyone have heard about her book, Sách Ba Lô Lên Bà Đi. I cannot translate it into English, so maybe welcome Huyền Chip. And Chip, can you unmute yourself and introduce yourself to all the audience today? We have more than 1,000 audience joining the Zoom meeting today, and another 1,000 that is watching on the live stream channel.
Wow, are we live streaming? Hi everyone.
Yes.
My name is Chip. I'm just enjoying the chat. Thanks everyone for the warm welcome. So yes, in Vietnam, I wrote this book, Sách Ba Lô Lên Bà Đi. I got a lot of stone like ném đá, enough to build a house. So it was really. So then I went to college, and then I studied engineering. I fell in love with computer science, and now I'm working on my startup, which is to build infrastructure for real-time machine learning. And I'm also teaching at Stanford, so I'm teaching this course called Machine Learning Systems Design, and a lot of materials for the course are online if you're interested in checking it out.
Thank you for your introduction. So so please wait for a moment so our technical team can put you on the spotlight. So
I think maybe it's better they don't see me. So
no, they should see you. It looks incredible tonight.
Yeah, actually,
it's
Don't.
yeah, honestly, I'm a big fan of Chip. Yeah, from your journey to the AI and your development right now. Even I know now, yeah, I still follow you on Facebook and Twitter.
Okay, I hope you don't unfollow me after this event.
Okay, yeah, definitely not.
I'm excited to read the book. Did you write the book? Is it in Vietnamese?
Yeah, the book is written in
Oh.
Vietnamese.
Oh, that's nice. I would love to check it out.
Okay.
Okay, so it seems like the live stream channel can see you, Chip, very clearly, but on the Zoom channel.
Oh, is this a live stream chat? Yeah. I want to see the live stream chat.
Yeah, there's a live stream channel as well. So maybe the technical team, can you push the put the live stream link to the chat so that everyone can see? It's an option for you, everyone, if you want to see Chip. Yeah, on the Zoom link, I can only see me and Tuấn. So I hope the technical team can. Yeah, now you go. Here you go. Perfect. So welcome. Now you are on the stage. Yeah, it's a virtual war right now, and to let everyone know, both I and Huynh is actually now in North America. So we are at the moment we are at the night time. It's opposite of Vietnam. I know that people in Vietnam now, they just had breakfast and maybe start to work. So, and I really appreciate that everyone join our discussion today. So first of all, let's start the discussions, and the other guests will join us soon. Okay, so we have more time to talk to Chip at the beginning of the sessions. So first of all, as I mentioned, our guest, Chip, is an adjunct professor at Stanford University. But she also a founder of a few startup companies.
One startup company for now.
Okay, one in data domain. So Chip, can you let us know about your projects a little bit, and why do companies nowadays have to pay attention to data-centric approach and ML ops direction? Yeah.
So I'm really glad that you organize this web beta. So I think the companies that we work with are very big on data-centric ML. So previously I was with a Snorkel AI, which is a end-to-end data AI platform built on top of programmatic labeling. So I think we know, so we own, a lot of people already know that like machine learning is part code, part algorithm, part data. So the part of algorithms, the model has mostly been commoditized. So a lot of people nowadays like just go to Hugging Face and get a BERT model. So what differentiate companies is the data that they have, the feature that they have. And when I talk to some companies, they actually have stopped iterating on models. So like they don't like spend a lot of time developing new models anymore. What they do is that they retraining the model on a newer data. So they iterate on data, and iterating on data gives them like much better return than iterating on model. So definitely, so previously the last company, Snorkel AI, which will help companies like relabel data very quickly. So it's doing automated instead of like manual label the data. And my current company would be infrastructure for companies to get access, like for data scientists and machine learning engineer to get access to like fresh data very quickly. And you can retrain the model very quickly. So you don't have to retrain the model like every month or every day, but you can retrain the model like every 5 minutes.
So the two companies share the same emphasis on data. So why data is so important? I mean, I'm asking this question, but I think everyone knows it. But still, I want to discuss it a little bit more about the importance of data. We all in machine learning know a very famous saying, garbage in, garbage out, right? So, but people nowadays, they compete. I saw most of the companies like Google, Facebook, and many companies are competing on building larger and larger models. So why people now start to realize that data are so important? Yeah, maybe Chip, can you give us some highlights about this?
I think I also want to hear from Tuấn as well. Yeah, I would love to learn more about what Tuấn is doing and his thought on data.
Yeah, actually, I want to say about my project. It's called AI làm thơ. Actually, like we make the Vietnamese poem on look back 6 and 8. Yeah, actually, like after this project, we use GPT is the basic model, and we develop from it. But actually, I found that like the data is so important because like we call the data from the website and a lot of sources. And so people assessing and focusing on the data is the most important in this project. And yeah, actually, everybody can check it out on the website, ilamthơ.com. Yeah,
I'm gonna share to my dad. He's a big fan of To Look Back.
Yeah, actually, like, yeah, for example, like we still put it on the website, and I found out like in the event like Vietnamese Women Day, actually like the number of users accept and use it a lot. Yeah, we have a lot. Yeah, and even like some of my students said like it's a useful tool for them. I mean to make a poem for the girlfriend or for the classmate. Yeah, as well. I hope that is doing interesting. Yeah.
Yeah, Tuấn, you heard from Chip, right? It's very important to have a kind of continuous improvement in AI models, right? And what have you adopted for your AI làm thơ project? What do you think about the importance of the quality of your data when you train the model? And do you have a plan to keep improving it in the future?
Yes, actually, like currently, just like we collect a lot of data and people set it and we build the model, but we still, lack of the pipeline, so that like automatically we have more data and we continue to train the model. Probably I will look at the pipeline and how to people set, how to train the model again. Yeah, probably I could look at the platform like Chip said before.
So Chip, so your company is building a pipeline platform for companies to keep improving their models and data. Am I right?
Yeah.
So how does the pipelines look like? What is a pipeline, and can you tell it to the audience to learn from it? Yeah.
So we're very early process of building it. The company is pretty young. It started in like August this year, so it's only 3 months old. So yeah, we still have a lot of things to do. I really like the question you asked earlier about like why data is important. And should I go back to that question?
Yes, please.
Yeah. So am I speaking okay now? Because I saw some chat say I should speak slower. Sure,
you can.
Yeah. Okay. So so I think that's the first thing is that like like Phong said, like garbage in, garbage out. So the model is not going to be better than the quality of the model is going to be better than the quality of the data. Like if the data is bad, no matter how good, like how many parameters or how many layers you have, the model is not going to perform well. So better data lead to better performance, which can lead to better returns for the business. And fresher data can give, so we know that like data changes in productions, right? You guys are pretty familiar with things like data distribution shift, concept drift. So the longer the model is in productions, the worse the model performance is going to be. So if you wait too long to update the model performance is going to degrade and can lead to like really bad return. For example, I talked to a like Stripe, right? Stripe is a payment company, and they have a model to detect fraud, and it takes them because like people like fraud patterns change very quickly. Like they always scammers come up with new patterns very, very fast, and the fraud detection models like decay after like hours. So if you wait like a week to change, like update the models, you lose a lot of money on fraudulent transactions. So you need to update the model very quickly. So it's another use case you're pretty familiar with. Are we in the audience? Are you guys like TikTok users, or is it like TikTok? Okay.
Yes. I think many people are using that nowadays.
Nice. I need to learn how to use TikTok. I just feel like I'm feeling so old. So TikTok. So when you log into TikTok, you scroll, and then TikTok learns a preference very quickly. So like it helps you to like, it helps companies to be very sticky models. As in like they can like adapt to that preference very quickly because preferences online change quickly. So like if you can update the model with better data, you can like adapt, make it more adaptive to users' preference. And I think another thing is really big, it biases, because data encodes a lot of human biases. So I think we have seen a lot of cases when the data collection process has a lot of selection biases. So it performs well on certain subsetted users, but not well on other subsetted users. So if we have some if we have some way of like monitoring the model quality production, if we can find like, if we can see that, oh, the model performs really well for this subgroup from like of this subgroup of users, but doesn't perform well on the other subgroups, then we can detect potential bias and it can improve the system.
I see. Yes, it's a continuous battle, right? Because the dynamics is changing very quickly nowadays. With lots of data has been generated, every minute, every second. So I believe that a pipeline to improve the data quality and to retrain the model to catch up with the changing of the changing environment and the dynamic environment is very important. So one of the last questions before we receive the next guest to you, Chip. So I heard you said about a platform for data. Does it include data labeling process?
So our platform is not for data. Our platform is for development and deployment of model as a whole, and data is a very big part of it. So in the current process, so our what we're doing is a little bit different from the current paradigm. So right now, what a lot of companies do is that they develop models offline, and then they have some other like people like evaluate the models, and then they put the model online. And then if you want to update the model, then you have to like somebody go into the data warehouse and get data, extract features, and then train the model offline. So in our platforms, the gap between offline and online is like a lot, it's very thin. So like the models is like, you can, because you continually update the model in production, you continue getting into fresh data. So like the production environment and development environments are like almost the same. So yeah.
I see. Thank you very much for your answer. So I saw the next guest has been ready to join us. So please welcome Miss Lin He. So Lin, can you open your camera and say hi to the audience? Hello, Lin. Can you hear us well?
Hi, everybody. Yeah, I can hear everybody. Can you all hear me?
Yes, we can hear you well. Thank you very much for joining us today. Let me introduce to you. So my name is Phong. We met before in discussions prior to this conversation. So I am the organizer of the Data-Centric competition in Vietnam. Together with Tuấn is the technical lead for the competition. And we have Miss Nguyen Chip. She's one of the most influential in Vietnam for machine learning and AI. And please welcome Lin. So when I reached out to Andrew, and Andrew told me that Lin was the technical leader that pushing the data-centric AI competition, the very first one in the world. So I'm really glad that I can have you here today and discuss about the direction of data-centric approach. So Lin, can you introduce yourself a little bit to the audience?
Yeah, I'm really happy to be here. Thank you so much for inviting me. And it's such an honor to be on a panel with everyone here. Just a little bit about myself. So I work at deep learning with deeplearning.ai. I work closely with Andrew Aang about developing data-centric AI movement. Also work on some of the courses that he teaches on Coursera, like DLS, deep learning specialization. My background mostly is into interdisciplinary applications of AI. So I did a Fulbright research project on using one-shot detection to detect motifs in painting data sets. So I really am interested in applications of AI to humanities. And yeah, at deep learning, I also do some policy work. I'm interested in tech regulation and tech ethics. So yeah, it's a bit about myself.
Incredible. Yeah, we have two most women in data science and in machine learning. That's a very, very powerful and influential. Thank you very much. You know, I think many people in Vietnam has known about deeplearning.ai since it's one of the most popular online learning platform for us, because we are very hungry for AI knowledge. And thanks to deeplearning.ai, it opened the door for many young people in Vietnam to learn about machine learning, to learn about deep learning. So I would like to, on behalf of them, on behalf of the young generation, I would like to say thank you for opening such a great platform. Maybe many people here have used that platform to learn about deep learning and AI, even including myself. So everyone, if you have learned this platform, you can, you know, on the chat, you can just type #1 there, and to say that deep learning .ai is #1. So you can see that so many people are typing right now that they have learned from the platform. That's incredible. Yeah, we have we have a few people in Vietnam also very enthusiastic in AI education. They have wrote books for young people to learn machine learning in Vietnamese, like Tuấn in here. He also has written a book about basic of deep learning. And I think he has a lot of inspiration from deeplearning.ai, right, Tuấn?
Yes, actually, like, yeah, I also, I'm a student of like annual course on Coursera about machine learning and deep learning specialization. So yeah, I learned a lot from deeplearning.ai.
Yeah. How about you, Huyền?
I actually took Andrew's course when I was in college, and I probably cried through the midterm. The midterm was very difficult.
Yeah, so we were talking about data-centric approach, Lin. So since you lead the very first competition in the world, so can you actually tell us about what's the definition of data-centric? So at least we make sure that we are on the same ground for all the audience here.
Yeah, first of all, I'm really happy to hear that there are so many people here who have taken the course. I'm always telling Andrew that, you know, it's so fun working on the courses, but we never get to see the people that it's impacting. So it's really nice to see, even if it's just saying ones in a chat. Thank you all for taking this course. I'm sorry when that you had to cry during the midterms. I hope no one else has cried from this course. But back to your question.
I learned a lot. Yeah. So.
Okay. Yeah, it might be different in person or something, but yeah. So back to your question, we've been sort of developing the idea of data-centric AI for a while, and Andrew actually had to sort of come around to this idea himself. And I think the definition that we've settled on is it's a discipline of systematically engineering data for an AI system. And a big part of this is, so an AI system is your data plus your code, right? Which is oftentimes a model or an algorithm. And there's been a lot of work done on the model side. And it's, you know, the very new, fresh thing to do, like building new model architectures. And because of this, I think a lot of the improvements have plateaued in a certain kind of way, and approaches to engineering data sets have simultaneously lagged. So I think people have been, working data engineering and working with data, and this is not to take away from any of those efforts, but I think at times it's sort of ad hoc, it's cumbersome, and there needs to be a way to systematically work on it, and also for it to be valued in the same way that being able to create a new model architecture would be. So these are sort of it's sort of a position to focus on the data first instead of focusing on the model. Was the perspective behind data-centric AI. Though I think Andrew's coming on later and he can probably speak more to that.
Sure. So I heard about machine learning ops, or we call it ML ops. So how does this data-centric, the term data-centric and the term ML ops, how are they related to each other? Maybe Lee, you can answer this first, and maybe if you have any addition to that, please.
Yeah, I guess I can go first. So
yeah, sure.
ML ops is a relatively recent development. So I believe Dee Scully from Google was one of the first people to come out with a paper that sort of catalyzed the creation of this field. So his paper on hidden technical debt was really influential in creating a ML ops community. And a big part behind this idea is, it's a term that's borrowed from software engineering, right? So when you're writing code for some software engineering project, sometimes you do a lot of things to move very quickly, but at the same time, because of that, you sacrifice a lot in terms of maybe reusability, or there are some bugs. Once you change, module A, maybe it affects module B and it breaks it. So with software engineering, that can sort of be fixed by isolating pieces of your code, right? So, if you break function A, it won't affect function B. But with machine learning systems, everything affects everything. Changing anything changes everything. So if you change one image or one hyperparameter, there are all these hidden dependencies that arise and you didn't know about. So it's a debt that you have to pay off eventually. So I think with ML ops and its relationship with data-centric AI, I think it's also a push to realize that you have to really track and monitor your AI systems and make them observable. It's sometimes you think you have a model with 87% accuracy, but what does that actually mean? It's performing super well on one slice of data, super poorly on another slice of data. It's really important to understand on a very detailed level what your model is doing. So that's sort of the relationship between ML ops and data-centric AI.
Thank you for your answer. Chip, do you have any addition to that?
Yeah, I totally agree with Lynn about the importance of having to monitor the quality of data. So I think there are many reasons why a machine learning system could perform poorly in productions. And the hard part is not just to detect when something happens, but what causes this. So I talk with several teams. So Google is of course a pioneer in this, and I think many use cases when so think about a machine learning system that's many different teams with different expertise involved. So they have the data science team developing the model, and they have an ops team to deploy the model. So when something happens, it's very hard to say who should attend to that matter. So for it could be that I've seen the case when the it looked like the model performing poorly. So the ops team was like, "Hey, data science team, go and fix it," because the thing is a model problem. But in reality, it's something in the platform because they changed some code in the data platform, and now some of the features are missing. So there's a bug that's actually caused by the platform team. So it's very hard to pinpoint exactly. And if you don't design the system in a way that to let you like ask the question, the state of the system any point in time, it can be impossible to debug.
Thank you for your answer too, Chip. So we have a very interesting discussion about data-centric and machine learning ops. So let's talk a bit about the competition. So Lin, you one of the key member in hosting the very first data-centric approach competition. What is your experience when hosting the competition? What is any difficulties, any memorable experience that you have when making the competition?
Yeah, I think the first thing that sort of jumps out at me is seeing the incredible work that all the competitors put into the competition and the techniques they used, and just like really people worked so hard on this, and it was great to see the innovation that came out of it. People use some really complex techniques like active learning to select the best data, and we were just really, really impressed. So I think that's one experience that we took away from it. In terms of any problems, I think perhaps one was just we had to train so much. There were so many competitors, and we had to train so many models. And even though we capped, I think, the data sets at 10,000 images, tiny images, it was we used a platform, Codalab, and it was a lot to handle for them. We maxed out on other GPUs, the time limits. It was a whole engineering process. And I'm not sure if, since you've started your competition, I don't know if you've run into some similar issues or anything like that, but it was certainly an engineering feat to process all of the submissions. But yeah, I would say that was...
We talk about it a bit later, so please just share your experience. Yeah.
Okay, yeah, we can commiserate. But yeah, and I think another thing is, I think it's inspired a lot more benchmarking across the some different companies. I think ML Commons has been doing some benchmarking work, and they're trying to create some industry benchmarks. And I think we just all realize that we need a better way to test models and to understand their performance. So yeah, I think we're excited to hear some of the winners of the competition present at NeurIPS, and hope it sort of inspires more efforts in this area.
Awesome. So if you have a time machine like right now to go back to before you host the competition to change only one thing, so what would you change?
Okay, I have to think about this.
Would you prepare more GPU cluster, or would you going to start the competition earlier, or whatever you can think of,
Yeah, I think we definitely would have tried to prepare better for this. I think we would have worked with the engineering team at Codalab more earlier along so that we could prepare for every day is like over 100 training submissions. So I think, and especially with people trying to spam the leaderboard, and I think that's something else is one is just really trying to make sure we have enough resources to process all the submissions, and also making sure that we early on had a better way of checking for people who are maybe spamming the submission board or something like that. It was definitely a beta test, and those are probably the main. Yes, for one, but maybe those are the two things that I would go back and change. I'm not sure if
Totally.
you run into similar issues.
I'm sure your next competition will be much more prepared and will be perfect next time. So Tuấn, yeah, can you share with the audience and Lin and Huyền Chip about FPT software AI data-centric AI competition, and do you face the same challenge that the first original one has faced? Can you unmute yourself?
Okay. Yeah, first of all, I also participated in the Data-Centric AI competition that Lin hosted. So yeah, actually we learned a lot about the lesson. For example, Lin said about the computational resource. Actually, like the competition lasts for 3 months. However, we know it a little bit late. So just we joined on the last month. So yeah. However, we are still on the top 3% of all the submissions, and I found it so interesting, like because normally the AI contest focus on building models. Yeah, I mean build model to reach the best performance. However, the data-centric competition is kind of like the model is fixed, and the candidates need to people set and augment data to achieve the best performance. Yeah, that's the reason why like we hosted the very first data-centric AI competition in Vietnam. So to motivate people about the importance of the data, people setting data and augment the data. And yeah, because we know the problem of power resource in the data-centric AI competition, so we calculate it carefully. Actually, like currently we have 2 GPU, 2 server, and each server have 6 GPUs. To people set all the submission. We calculate it carefully. Like we estimate how many users, we limit how many submission per week, and to make it on time to release the result for the user. And also like I also face some other difficulties, such as choosing the model. For example, like we choose the YOLO model for the baseline. However, which model, YOLO S, version S, L, or S, for example, and the parameter as well. We have to experiment a lot so that like we can give the baseline for the participants. So that, like not too high but not too low. For example, like if it's too low, like probably the participant can boring and they don't want to try it. And one of the most challenge that I had in this competition so far is like for the same data set, but each time we run, we have a different result. Probably like we try a lot about the setting seed on NumPy, on PyTorch. We set deterministic, everything. But like we can try a small model on CNN model, the result is the same. However, on YOLO, it's different. And like it's a headache, like, because like each time user submit the data, the result on leaderboard is different. So like, yeah, we debug like for a week, but we can't show it. So we decided to like more fair for user. We run it like 5 times and we take the average, like it's more like human, the power resource, because like we need to run each submission 5 times. However, fortunately, we still have, calculate the result and we still return the result on time.
Yeah, we learn a lot from the competition as well. I believe so. Tuấn has also calculated very carefully, and thanks to the advice you gave us from our discussions prior to our hosting the competition, we actually have learned a lot from you guys as well, and carefully hosted this data-centric AI competition for the Vietnamese community, so they have the chance to learn from data-centric approach. And also, I would love to raise the awareness for data-centric approach as well. So yeah, Winchip, so you can see that how exciting the competition is. And do you have any advice for our competitors, the participants of the competitions?
Yeah, I think I miss the days when we was doing competitions with friends, because we really learned a lot from it, from the competitions. So I think so my friend, I have a friend who is extremely good at winning competitions. And so one thing that he told me is that when competition go on data set, the first thing you need to do is to understand the data really well. And it would happen like for competitions like on Kaggle, they often like a lot of data leakage. I'm not saying that it should like exploit data leakage, but there's usually something like very obvious about the data that you can use to like boost up model performance or like to avoid pitfall. Because if you train the model using data leakage, then it's not going to perform well on the test set, because if that the same leak is not available during test time, the model is going to be like doing really well on the during training, but then you submit it and it got like bad performance. And things another thing is yeah, it's interesting about Data-Centric, because I know that like Kaggle competitions, a lot of winning solutions are like ensemble, but for Data-Centric, do you allow ensemble, or everything is just like purely data?
It's purely data. The model was fixed, so you cannot use an ensemble.
I mean, like,
Wow,
I think it's a problem, because like we need to train a lot, because the user submit the data and we need to train the model.
Yeah, so but there's a problem with like when you train a model a lot, you probably heard about like the hypothesis testing. So like if you have like a lot of hypotheses, right? By chance, one of hypotheses might perform really well. So when you train the model multiple times, so just by chance, one of the models that perform very well doesn't mean that it's gonna perform well on other data. So I'm curious about like whether we have a setting where we can actually deal with like data distribution shift, because I think a lot of things I see with research is that you have historical data and that the data is fixed and it doesn't accurately reflect the data that models will actually have to work on in production.
Very good questions. So Tuấn, maybe you can answer these questions. We believe that we have prepared 2 private data sets, and there's some certain different in distribution, but maybe Tuấn can share with you a little bit about this.
Yes, like actually, like we have the 2 private tests, actually, like one for the leaderboard and other part for the private test, and the result, the contest finally on the on the private test. So yeah, we think about like the participant can overfitting the leaderboard, actually, like because they can submit a lot of time, so they can overfit the leaderboard. So yeah, we prepare the private test and just like show on the final of the contest to avoid the problem that we mentioned.
Yeah, so there's some shifting in distribution in the training data set and the test data set. I believe that's what Lynn also have done that for her competition as well. And yeah, Lynn, can you tell me a bit about your distribution between the training data set and your test data set in your competition?
I'm not so sure if it replicates sort of the distributional shifts that happen in deployment. I think it's for our competition, it was, I think the test set was pretty stable, and it was mostly just a split between we just aggregated a ton of data, handwritten Roman numerals, and then split it. So I don't think we spent a ton of time like specifically engineering the test set to be a certain way. But yeah, I imagine that it's while these competitions are useful in certain senses, I don't think they are able to maybe replicate what it's like to have distributional shifts in deployment in the current format. I don't know if people have ideas for how we could achieve that, but yeah.
I think one thing I see a lot people do during research is that they split a data randomly and not by time. So one of the cause of leakage is when you don't treat time-based data well. So for example, so a lot of trends tend to be correlate over time. So one easy example is stock prices, right? Like when the market go up, a lot of stock prices gonna go up. So if you get the data stock prices from the last year and just randomly split them, so you can basically it's a trend data, include data from the future. So the model learned all of that randomly split, and it can detect trend what's happened in the future. So I think one way to cope with that, like just like be very careful about splitting. So instead of randomly split, you do it strictly by time. So using like the data from the first 10 months as training data and test on like invalidate on data from like 11th month on a 12th month.
Very good argument, because you know, when because our competition topic is about detecting mask on the people, and you know, at the beginning of the pandemic, everyone seems to wear masks very strictly. They follow the rule by wearing the mask very carefully, by covering the nose, but you know, later on, they started to have variants. Some people were wearing it under the nose. Some people with, you know, even like putting the masks under the chin. And there are more masks coming up on the market, right? At the beginning, there are masks with just blue colors, white color, and then there's some masks with flowers on it. I don't know, but I think it's a very good argument. We don't know the future data, the future of the testing data. So it's a very important to treat time as a factor in the data set to split it. Thank you, Chip, for your contribution to the discussion. This is really it's a good point. And okay, so the next question I want to ask, and Andrew will be joining us in a moment soon. So I want to ask Lynn this question. So we know the advantage of data-centric approach. So what is the drawback? Oh, hi, Andrew. Hello. Yeah, we are looking.
I think, yeah, it's nice to see all of you, and thank you for having me. I think, don't want to interrupt your conversation. Please keep doing what you're doing, and look forward to saying hi to everyone, chatting with everyone a little bit.
Yes, I think there's some familiar facts you saw here. I think you believe you have talked to him, Chip, before. So I'm asking the questions to Lynn. We all know and maybe you can jump in and answer the question as well. We all know the advantage of data-centric approach, that to improve the quality of the data and help the model, you know, surpass itself. But is there any drawback? Actually, I want to discuss the other side of the coin. Is there any drawback when companies and people pay attention to data-centric approach?
I guess maybe one drawback I could think of is there's just not been that much focus on innovating on the data side. So I think there's been a lack of tooling, a lack of systematic approaches to, you know, if you wanted to take a data-centric approach to your own data set, you know, I think sort of like pre-trained models and things like high-performing architectures are very widely available, but I think we're sort of lacking in benchmarks and lacking in systematic ways to look into your data, and companies that are really taking that super seriously. So and maybe another potential drawback is that all the hype right now is working with models, right? Everyone's wanting to build, you know, live in GPT paradise and build the biggest, best models that can do everything. And, you know, data-centric AI is, it's a bit more specified. You aren't going to be necessarily working with the hugest processors, with the largest models that can generalize to any topic. So I think it's going to take a bit of patience with believing in the approach and making sure that, you know, you understand your data, and it's a task that takes a lot of diligence, I think. So, yeah.
Yeah, thank you, Lynn, for the answer. Yeah, Professor Andrew, do you have any things to add on?
Oh, no, just it's great to be here, and good to see you, Lynn. Chip, huge fan of Chip's work for a long time, and Fong and Tuan. Really excited, to join when I heard about you're organizing this data-centric AI competition.
Yeah, first of all, I really want to say thank you for inspire a lot of us for the first ever data-centric AI competition in the world, and we love it so much. So we brought it to Vietnam for the Vietnamese community to try it, and we ourselves, I and Tuấn, has participated in your competition, and we ended up on the top 3% of your leaderboard. So. And we hope to also speak in your workshop in Europe this year too. We are really looking forward to it. And you are here, you are an idol for many young AI lovers in Vietnam. You can see when you join, many people actually say hi to you, and they actually show their appreciation for your course on Coursera and on deeplearning.ai. And we briefly mentioned how impactful deeplearning.ai has been for the Vietnamese community. So everyone in here, if you want to send your appreciation to Professor Andrew, you can put a heart-shaped icon in the chat. It's smaller than 3, or say thank you, whatever. You can see Professor Andrew, that so many people want to say thanks to you. And we are a very young nation. Lots of young people love math, and Vietnam has a lot of gold medal in international math Olympiad competition. And we all love, many people love programming and now machine learning, thanks to you and your vision in democratizing AI knowledge. So I want you to ask you a question. So what is your vision?
Just say, I think you're too kind. I think that, frankly, for almost all my life, people are giving me way too much credit. I find that I was really inspired when I learned about the growing machine learning community in Vietnam. And I think, one of my former students, Quoc told me a lot about the local community. So I feel really honored and privileged to see the hard work that so many of you in Vietnam are doing to learn about machine learning, study, try things out, innovate at the cutting edge of data-centric AI and other topics. And I feel honored and privileged to be able to play a very small role to support the great work that all of you are doing in Vietnam. So thank you also for having me here today.
Yeah. Okay. So what I want to ask you, what is your motivation behind creating this data-centric AI competition? What do you want to? What is your message to the world and to the other many companies?
And tell a little bit about how I maybe stumbled my way into thinking about data-centric AI. When I started, when I started landing AI a few years ago, what I had done was, I built and led AI teams in like Google and Baidu, right? So I helped 2 great consumer internet companies build up, pretty good, very good AI teams. And so when I stepped away from my role leading those, I felt I've done it in 2 consumer internet companies. I don't want to do it anymore. Someone else should keep on doing that. Lots more internet companies need better AI, but I just didn't want to do that anymore myself. And frankly, I really underestimated. And what I wanted to do was take machine learning to other industries. And frankly, I underestimated the difficulty, and I did not understand several years ago how different the recipe would be to take the amazing things that many people in the software tech world had built to take it to other industries. And after doing, frankly, probably too much consulting work and too much custom work, I started to develop a point of view on some of the common challenges that's making it difficult to why the recipe for AI in Google and Baidu and Facebook and Microsoft, why it just doesn't work for many other industries. And I feel like one of the problems was the cost of customization. Instead of building one giant monolithic web search engine to serve 1 billion users and create tons of value, we figured out how to get dozens or hundreds of engineers to build one AI system. But in other industries, like manufacturing, instead of one homogeneous monolithic system, you kind of need maybe 10,000 custom AI models for 10,000 different factories. Or in healthcare, I think every hospital codes electronic health records differently and they need their own AI system. So the challenge that all of us face, all of you watching this face too, is for these other industries, how can we build not small number of monolithic giant systems, but instead support an industry to build 10,000 custom models. So I did not feel like I could, build a team of 10,000 machine learning engineers and ask them to run all around the world to do all this custom work, and felt that the only way to maybe make this happen is to start to build tools to let manufacturing firms or other industries I'm not working with, maybe let healthcare firms or logistic firms do their own work to customize the data needed to feed into the machine learning model. And I think a lot of people have been engineering data for a long time. It's not like I invented, engineering data, but I think that's what a lot of people have been doing intuitively is starting to maybe crystallize into a set of repeatable principles and then even tools so that a lot of people, rather than just experienced machine learning practitioners, can do that. And after brainstorming with a few friends, Lynn over at DeepLearn.ai, my friend Dylan Laird at Landing AI, brainstorming with a bunch of friends, we decided that holding a competition might be a little contribution that we may be able to make to help this movement coalesce and let lots of innovative ideas surface and then hopefully create tools to let more people do this well at scale.
I think it works very well. Yeah, lots of people from the competition actually learn a lot about the importance of data-centric approach, and they start to think deeper and deeply about like how they will use their system in the future. I think it's really work. Yeah, just from my point of view. And
just add to that, I feel like I think in this audience, maybe it's obvious to everyone, but I feel like one of the frequent misconceptions about data-centric AI is sometimes people still say, yeah, look, we know data is important. That is true. We've known data is important for many decades. But I think the missing link that is still, hopefully, maybe all of you can go spread the word, help more people understand this. We've known for decades that data is important, but I feel like a lot of the work to engineer the data was very ad hoc. It's like one brilliant engineer through skill or luck making the right decision to clean up this data or whatever. But the thing I'm excited about is just as deep learning, took a long time to become systematic and repeatable. I think that we're in the much earlier stage of making how we engineer the data to be systematic and repeatable. I know that all of you in this audience, maybe you have a deep appreciation of that, but I hope you can go help spread the word, because it's not just about recognizing data is important. It's that now that we've all recognized that, maybe have for a long time, what are the repeatable systems and processes and principles that let us get it to work well, so that many people can get it to work well.
Yeah, thank you very much for the comment. I think Chip is actually one of the most active followers for that direction, and she is building companies that also helping people to do that. Right, Chip? Do you have any add on to that?
Thank you. So it's really nice seeing you, Professor. I was just sharing with people here. It's like I took the course and it was difficult, but I learned a ton. So I really appreciate a lot of things you're doing. So for data-centric, so I agree with you. It's like having good processes to make data processing, data quality control more repeatable, more reliable is very important, and that's part of what we are building. And I don't want to turn it into like a pitch. So basically, we're building a platform for allowing to companies, data scientists to like directly access fresher data, update the model more frequently to adapt to the changing environment.
Oh, that's really cool. What's the name of the thing you're building? I would love to learn more. I'm sure others here would love to as well. Sorry,
so we are.
Must you repeat yourself?
Yeah, we're very early. So I think we are only 3 people for now. We are 3 months old, and it's named Claypot.
See, cool. No, right. That's really exciting. I look forward to learning more. In fact, I think some people know this. I've actually followed Chip's writings on ML ops. I think Chip, has been a really huge force on helping a lot more people understand ML ops. So I look forward to seeing you and following Claypot's progress, Chip.
Oh, you're too kind. Thank you so much. Oh my God, you said you like my writing. Okay, so I picked.
You know that she has cried in your midterm in your course.
Oh, really?
No,
wow. Sorry about that.
Cry in a good way, out of happiness.
Yeah, in a good way. Cry out of happiness. No.
Okay.
Not too pressure. So by the way, my next question to you, Professor Andrew, how will data-centric AI will impact to the AI in non-technical industries? How will it help?
Yeah, I feel like many of us have read these reports saying that AI would create tremendous amounts of value across the economy, across all industries. Candidly, from where I'm sitting, it's clear it's done that in consumer software internet. In almost all other industries, honestly, I'm not seeing much of it yet. Maybe financial services, but walk to a hospital, walk into a factory, walk to a logistics operation. There are a lot of proof of concepts, demos, ideas. Sometimes there are actually good teams working on it, but in terms of large-scale adoption, I'm just not seeing it yet, frankly. And I feel like one of the keys to unlocking all this value will be data-centric AI, because the fact of the matter is factories, logistics shops, healthcare, they operate in very heterogeneous environments. One of the great things about the software world is when one company updates its web search engine, you could push that web search engine to everyone in the world, so everyone uses kind of a same thing from one company. If you go to that, or when someone updates their smartphone OS, they could push it to everyone. And so there are a few versions of smartphone OS floating around, but not that many. So the software world, we've managed to build surprisingly homogeneous environments and products, which is why these monolithic giant AI models work. But in healthcare, every hospital codes its electronic health records a little bit differently. I don't know how to make all doctors and nurses and medical coders in the world conform to one standard. It doesn't seem practical. So if the reality is every hospital, every healthcare system needs a custom AI model, if you expect every hospital's IT staff to, take a model-centric approach and invent the next generation of a transformer network or something, we could try, but I think it's going to be quite challenging. But if we can create data tools so that the healthcare administrators, that the doctors label the data, express their knowledge about how to read electronic health records by labeling the data, that, to me, seems to be a more promising path to help all of these different organizations build the custom machine learning models that I think they will need in order to take machine learning to these other industries. So I sometimes talk about manufacturing because I spend a lot of time there, but I think this recipe of building tools to help the customer engineer their own data will be an important recipe for taking machine learning from consumer software internet to many of these other industries.
I think thank you very much for your sharing just now. I think it's very cool to see that other industry who are not technical in terms of like IT, they can actually use the value of data-centric approach to apply to their own domain and get the value of machine learning and AI. I think it's very important. And
let me add one other observation.
Yes, please.
I know we tend to read in the news about GPT-3 training on a bazillion data points or words or whatever, and we tend to read about ImageNet, 1 million images. I once built a face recognition system with 350 million images. So we tend to read about these giant data sets. I've been surprised over and over. Even now, sometimes I'm surprised at how good you can get a deep learning system to work with 50 images or 100 or 200 images. And the secret sauce, which is really important, is you have to find a way to engineer those 50 training examples to be really representative. So just like, if you show me 50 pictures of something, you want me to figure out what you're showing me, well, please show me 50 good examples, not 50 noisy, blurry, whatever examples. And so I find that, again, consumer software internet often has the luxury of giant user bases and thus massive data sets. In many other industries, sometimes 50 images. I've worked on healthcare problems where we had 150 pictures of a medical image. That was all the data that existed. I don't know where to get more pictures of that condition. Or manufacturing, where factory has 50 pictures of a defect. They didn't make any more defects. That's all the data that exists. So I think being able to get machine learning systems to work, even on small data sets, seems like another critical piece of the recipe for taking it to these other industries. And data-centric techniques engineer the right set of examples rather than only the giant set of examples seems like the other, at least one other crucial piece of the recipe for making machine learning work in these other industries.
I think what you share is really important. Our theme for our talk today, our chat today is data-centric approach, back to the basic. It's very basic to have a very good representation of data, and even like we need to have a correct label for the data. Actually, people made the label and people made mistake. It's very common, right? And if you ensure the quality not only in the representation of the data but also the label of the data, I think it actually helps your model a lot.
Yeah.
And I think it's a good time, to look back and to come back to the very basic of machine learning and to do the right things.
Yeah. Very much.
Yeah. So regarding to the labeling process, actually, I have the questions. So how to, labeling is done by human, and sometimes people have different opinion, and sometimes wearing, for example, like we are hosting the competition by detecting whether people wearing the mask right or not, whether they covering their nose, and some people will have different opinion. Sometimes, how do you solve the problem, or how do you mitigate the problem of discrepancy in data labeling?
Yeah, it's very interesting. I can tell you one thing I maybe used to do but don't do anymore, right? So I know that especially when I was leading AI teams in some of the large internet companies, one instinct is, the people don't agree on the label. Let's get a lot of people to label and make them vote, right? And then we'll go with the majority vote. It turns out, that's okay. It's maybe better than not voting. But what I've learned is that it's often even better to get the labels together and establish a consistent standard. So change the definition of labels so that they label it more consistently. One of the unfortunate effects of the conventional model-centric driven approach to a lot of great academic work in machine learning was done by people download their benchmark data set and then work on the benchmark, showing that they do better than others on the fixed data set and then publishing a paper. One part of that academic exercise, which was great because it drove a lot of machine learning progress, was teams wanted to show that they're superior to human level performance, right? Because, hey, it's like on this data set, I do even better than human labors. So I'm going to publish a paper and the reviewers will be impressed because I beat humans on this, vision or speech talk. So there are a lot of papers, including some that I worked on, right, of that genre. But it turns out that one of the ways that teams beat human level performance is if the definition of the labels is noisy, and so humans just don't know how to label it, or there are multiple ways to label it, and you kind of pick at random. And what I found is there's some problems where a learning algorithm can almost gain an unfair statistical advantage. If a learning algorithm knows that, 55% of humans label this way, 45% label that way, the learning algorithm can go up to 55% and does do better than people because it can measure the statistics more rigorously. And so this allows learning algorithms to sometimes gain that advantage that makes it easier for you to publish a paper. So maybe that's great. But if your goal is not to document in a paper that you beat human level performance, but if your goal is to, let's get a machine learning system that just works well rather than have documentation that works well, then it's much more effective to get the labels in the room, set some standard, whatever it is. Most of the time, any standard that's consistent is better than a random standard, and drive toward consistency of labels. And that makes the data more easy for the learning algorithm to understand and gets you a better algorithm. Yeah, Chip, you add to that?
No, I just want to add not all labels need to be manual. So I think there's a lot of progress in programmatic labeling with supervision that allow you to encode domain expertise into functions that can be automatically applied to a lot of data.
Yes, great point.
Interesting. Yeah, Lin, did you have anything to add? From your experience hosting the very first competition, I can see that some of the number that looks like number 5, but it's actually number 3. So, did you have any standard in labeling your data?
We had a rough standard. I think our HLP ended up being, so human level performance ended up being around 90.2%. So there were a lot of like around 10% of the images were labeled incorrectly or inconsistently. And I think with our competition, because the way it was designed, it was more of about filling in a gap of information. So adding more data so your algorithm can learn rather than, necessarily like creating a systematic labeling process. So perhaps that'd be a different competition, but yeah, I think ours is a bit more focused on maybe where data augmentation would play a role in data-centric AI.
Yeah, in fact, one thing I said about, so Lynn and team and Dylan and so on, organizing, doing a lot of great work to organize, doing a lot of work to organize a data-centric competition that we had run some time back. I feel like because there haven't been a lot of data-centric competitions, really, I felt like the design of the competition, it was a pretty tricky exercise. So for example, Lynn and team put a lot of thought into, like maybe a clean test set so it could evaluate things, but a noisy training set. And one of the limitations was we didn't know how to let people that submit engineer the test set because we still needed a way, right, to assess submissions. Whereas in a practical, project commercial setting, I change my test set all the time if my goal is to build a practical project. So actually, I don't know. I know Lynn put a lot of thought into design the competition. I've actually not answered this, but are there lessons, Lynn, that me and the rest of us should take away?
Yeah. Also, Hien also have mentioned about the very important in the practical setting. The test sets has been changing a lot, especially with the time as a one of the very important variable. Yeah. Tuấn, do you want to add something on the consistency of labeling?
Yes, actually, like for example, in the AI data competition contest, I will see the private test when you guys release the private test. I also see the, confusing label, like for example, between 3 and 5 and something like this. However, I think like in the data-centric competition like that, we also release the public test, so that like the candidate, can see like how we label the data, so that they can mimic it, and to label the best for the data for the contest.
Okay, thank you for the advice for the team. Yeah, Lynn, you want to say something?
Yeah, just to add on to what you said, I feel like we included a label book, and that's something that Landing AI does, is they include examples of how things are labeled, and there were some edge cases in there which we hoped would give some insight to the competitors as to how things maybe were categorized. And of course it's not comprehensive because it wasn't a second test set, it was a label book. But I think that's something that's really important for these problems, is establishing those clear standards, even if they're one person might think this 3 is a 5, is that everybody's clear that when it's written like this, it's a 3. So yeah, it was definitely, we definitely had to take some time to make some really bad looking numbers, and adding those in there was really interesting and sort of counterintuitive, but also kind of fun.
Yeah, totally. So as I can see, machine learning has been evolving so much in the past few years. So Andrew, Professor Andrew, I want to ask you, do you have any advice for machine learning and AI lovers who want to start their career? What should they do, and what skills should they build up to prepare for the very dynamic changing future? Especially for Vietnamese people, if you have any specific advice for them?
Yeah, well, I share a couple thoughts. So I think, I think that what I found, I actually give like a hour-long talk. I think there's an hour-long talk on YouTube, some ACM presentation, and another from the Stanford CS230 class, kind of on career advice. But I'm going to try to summarize an hour-long answer that you can find on YouTube into 2 minutes. I think that in machine learning, there's a lot of foundational knowledge that's worth learning, and coursework turns out to be a very time-efficient way to learn those things. A lot of knowledge is on the internet, but the advantage of coursework is it organizes it in a way that makes it time efficient. And then beyond the coursework, which is when you've exhausted, the useful coursework you can take, then I think most people, dive into project work, such as taking part in a competition like this, or working with local friends, or local university, or local partners in a project that often deepens your degree of knowledge and then lets you go on to do bigger and bigger projects. I feel like Vietnam is a very technically sophisticated group, and I feel like sometimes people ask me, should a country like Vietnam build its own web search engine? I usually say maybe not, right? That was like the competition of 10 years ago, and we already have pretty good web search engines that we can all use. But there are a lot of applications in Vietnam that you're uniquely positioned to build. You're probably in a better position to build a lot of applications to serve industries in Vietnam better than someone like me in the United States would be able to really understand it. So I think a lot of exciting applications that just were not possible as of even 2 or 3 years ago, because machine learning had not advanced the level of maturity yet. So I think those are the opportunities to do really unique projects that hardly anyone else in the world could possibly have a harder time working on than you, and doing those projects and doing bigger and bigger projects over time would be a good way to keep honing your skills. Oh wow, thanks Nia for finding YouTube.
Yeah, he shared with everyone the link on the chat on the resource you have mentioned. Yeah. Lin, did you have any advice for young people who started their career? Do you have anything to add on Professor Andrew's comments just now? And I mean, it's better if it's come up from your own experience. How do you grow to become one of the leading member in Professor Andrew's team?
I don't know if I'd call myself that, but I think for me, I sort of started my AI journey maybe a bit later than some would recommend. And I think that can also be sort of your superpower. So I really enjoy art and art history. And I think being able to add AI to that, and it becomes a very specialized field all of a sudden. So I think whatever topic you're already interested in, you can feel free to add AI to that. And I think that can make you unique and specialized in your own way. So yeah.
Thank you. Yeah, actually, Lin and Chip is a very special, figure for women in data science and in AI, and we really you two has really a role model for lots of women who really scared math and computers and so on. So, Chip, do you have any advice for women and for young, especially Vietnamese women in Vietnam who, someone just typed in the chat that this is AI is about math-centric, it's not about data-centric. So they seems to be scared.
So actually the first AI course I took was actually Professor Andrew Ng's course, CS29. And so I think I do realize that a lot of I think there's a lot of value in following some structured learning in the beginning, but then so like one thing that I think a lot of people underestimate reading textbook. So I just going through textbook and I do exercise and not just like skimming. I think like I usually take a lot of online courses, but then I just like watch the lectures and actually don't do the assignments and don't do the projects. And I realized I don't learn a lot from those courses compared to when I actually do the projects. So definitely like if I were to start again, I would try to like choose a few courses to take and go through the assignments project and try to like start it yourself doing a project of your choice. Like there are many ideas, there are many data sets out there. You can try to collect your own data set as well to understand like the difficulty of creating your own data set.
Yeah. Thank you very much. So I want to keep the time, strict for everyone. You may have another busy schedule after this. So maybe a very few last word from the speaker today. Do you want any message to send to Vietnamese AI enthusiasts and also for the data-centric AI competition in Vietnam? Maybe Professor Andrew, you can start first.
Sure. So maybe I think over the last many years, I've been really excited to follow the progress of the Vietnam AI and machine learning community.
Thank you.
So I think, keep learning, keep working hard. I think that especially in the unfortunate pandemic world where so much of work is online, for this somewhat tragic reason, your physical location has become less material than it even used to be in the past. And I think that with the very strong base that exists in Vietnam, I could absolutely foresee all of you in Vietnam playing a very large role in the future in the global AI community. So really, congratulations on the growth and rise of this thriving, very skilled community. And I hope all of you will keep at it and keep learning and keep doing this work on the cutting edge, like pushing the boundaries of data-centric AI and other things.
Thank you very much for your kind words, Professor. Lin, do you want to say something to conclude?
Yeah, I guess just to add on to that, I think it's just so wonderful to see everybody in the chat even and see people's enthusiasm. I think on the competition we hosted, we saw a lot of young Vietnamese talent, and I think it can only keep growing from here. And I'm really excited to see all these young people's futures in AI. So thank you for having us here.
Thank you, Lin. And Huyền Chip.
I think I really enjoyed the discussion and also really enjoyed the chat. It's probably like one of the most active audience I have ever been interacted with. So thank you everyone for making me feel so welcome. And thank you for organizing this great event. I think someone mentioned, I went to like K-12 in Vietnam, the first grade 1 to 12 in Vietnam, and then I went to college in the US. So actually they got to see a little bit of education. And I can say that's like, I try to stereotype too much, but I have seen this like a lot of the people I went to school with in Vietnam are, I think like the math program in Vietnam is much more rigorous than the math program I have seen in my school. So I think like a lot of students I have met in Vietnam are really, really good, really fast learner when it comes to machine learning. And some of the best engineers I have met are actually from Vietnam. So I think there are a lot of talent there, and I'm really excited to see more events like this, more people interested in machine learning and data science.
Yeah, thank you. And Tuấn, maybe some final words for the audience.
Yeah, I mean, like, thank you. In the last month of the competition, we will increase the, total time submission per week from 3 to 4. Because a lot of the participants asked for that. And also, like, we will also like increase the time for release the result on the leaderboard from twice per week to 3 times per week. Hope that like you guys will enjoy the competition in the last month.
Yeah, and as for me, I would like to say thank you all for participating in a very interesting talk today and discussion today. Thank you, Professor Andrew, for your time. Really appreciate your love and your attention to Vietnam, and also to the whole AI community who want to follow a data-centric approach. So thank you very much, everyone, and hope you all the best and stay healthy, stay safe in the pandemic. And goodbye, and hope to see you in person one day soon. Thank you.
Thanks, everyone.
Bye.
Thank you.